So picture this. I am standing there maybe 5 minutes before a dinner reservation.
Oh, no.
Yeah. And I am completely wrestling with a winter jacket that had just decided to become a straight jacket.
The zipper.
The zipper. It was stuck exactly halfway, like not up, not down, just locked in this weird purgatory of teeth and fabric.
Oh, yeah.
I mean, I eventually had to just step out of it like a banana peel.
We have all totally been there.
Yeah.
But strictly speaking, you weren't just fighting a stubborn fastener.
No.
No, you were battling a highly constrained tribological system.
A highly constrained tribological system. I love that description. And you know, that is actually our exact mission for this deep dive.
Yes, it is.
You're looking at the micromechanics of interlocks, the physics of friction, and why that little metal slider on your jacket is really a precision-engineered machine hiding in plain sight.
And a cam-guided one at that.
Right.
I mean, most people think a zipper is all about the teeth, but the magic is actually entirely in the slider.
So let's start right there. The slider is basically the engine. When you look at the schematics we pulled from the research, it's not just a hollow tunnel.
Not at all.
It's more of a control center.
Exactly. Inside that tiny metal body are these internal channels, which are called throats, and they form this 3D Y channel. So it is essentially a kinematic device.
Which is really just a fancy way of saying it's a mechanical transformer.
Right.
It takes the linear pull you apply, like when you pull up on the tab, and it converts that energy into lateral compressive forces. It's basically smashing the elements together from the side.
Precisely. And inside the slider, there's a very specific wedge or cam geometry. As you pull, that wedge physically forces the head of one tooth into the cavity of another.
Like a woodworking dovetail joint.
Just like a dovetail joint.
It is incredible precision for something we literally operate every day without even looking at it.
Oh, absolutely.
And speaking of precision and systems that need to run smoothly, let's actually talk about our sponsor, Embersilk.
Yeah, if you are looking to streamline your business or even your personal life, Embersilk specializes in AI training, automation, and software development.
Just like a slider coordinates all those chaotic teeth, Embersilk helps you figure out exactly where AI agents can coordinate your digital workflow to make the most impact. You can check them out at embersilk.com.
Highly recommend.
Okay, so back to the physics. You mentioned a tribological system earlier.
Right, tribology. It's the study of friction, wear, and lubrication. And when you look at a zipper under an electron microscope, the contact between the teeth isn't smooth at all.
It's rough.
Very rough. The interaction actually happens at these things called asperities, which are just microscopic rough spots in the material.
So it's essentially jagged mountain ranges rubbing against each other.
Exactly. And this is where a really fundamental physics principle kicks in, called Amanaton's law.
Right. So in this context, that law dictates that the friction force is proportional to the normal load, meaning the slider has to apply a very specific amount of squeeze, that's the normal load, to keep those teeth interlocked against the friction trying to pull them apart.
And it is an incredibly delicate balance. Whether those teeth are brass, nickel, or molded plastic, the manufacturing tolerances are razor thin.
Because if the gauge, like the actual width of the teeth, is off by even 0.5 millimeter, the whole system fails.
Right, the cam simply can't apply the right pressure anymore.
Which actually leads us perfectly to the biggest takeaway from all the engineering sources we reviewed, the failure mode.
This is the best part.
Because when a zipper splits open right after you've zipped it up, everyone assumes the teeth are broken.
That is the common misconception. But the big aha moment here is that the culprit is usually just throat widening.
The machine gets tired, not the track.
Exactly. Over time, the metal slider wears down, and that internal channel widens. Just a tiny, tiny fraction.
So suddenly it can't apply that normal load we talked about.
Right, it can't squeeze the teeth hard enough to lock them into place.
And you know what? This is actually amazing news for repairability.
It really is.
Because if the failure is almost always just the slider, you don't need to rip out the entire zipper tape and sew in a brand new one.
No, you just replace the slider.
Yeah.
Literally pop a new one on with the correct gauge, the compression is fully restored, and your jacket is completely saved.
It's a fix that actually makes sense. It turns what feels like a catastrophic wardrobe failure into a 5-minute DIY repair.
Totally.
It's honestly a huge win for fixing things instead of throwing them away. So I want to leave you with a thought. The next time you are getting dressed, take a second to look closely at that little piece of metal on your coat or your bag.
It's not just a handle.
No, it is a brilliant precision machine managing microscopic forces and friction every single day. And it makes you wonder, How many other tiny mechanical miracles are hiding in plain sight, just waiting for us to understand them?
I love that. And hey, if you enjoyed this deep dive, please subscribe to the show and leave us a 5-star review if you can. It really does help get the word out.
Thanks for tuning in, everyone. Stay curious.